minus second derivative of a fxy. Okay.
Yes.
This value d, if it is positive greater than 0 and second derivative of x greater than 0, then f has a relative minimum. Relative minimum. If d greater than 0 and second derivative of x greater than 0 2, this is minimum, relative minimum at a, b, which is 2, 3, let's say. If d greater than 0 and f of x at a, b less than 0, then f has a relative maximum. If d less than 0, then f has a saddle point. So this d, if it is positive, so we have maximum or minimum. If it is negative, we have saddle. Okay?
Okay. Yes.
If d equals to 0, then no conclusion can be drawn. We cannot say anything. Okay?
Yes.
That's it. I can, we can try this here. What?
Can we try a real example with real function?
Ah, yes. 1 minute. So d is positive, is negative, 0 is positive. We have two solutions. If f of xx greater than 0, so this is minimum. Minimum. If fxx less than 0, so the point is maximum. If d less than 0 negative, so the point is saddle. If d equal to 0, no conclusion. Okay. This is your file. Has one critical point and classify the critical point. We found that it has only one critical point, but we didn't classify it. Now we need to classify it through this. What we just said now.
But Ustaz, can we also again find critical point from the beginning?
Yes, we'll do it from the beginning. So from the beginning, step number 1, we will do df dx.
With respect to x, and it would be 4 minus 6x plus 2y. Yes, that's it.
And df dy with respect to y.
Yes, it would be 4 plus.
Which 4? This is 0. This will be 0, 2.
Yes.
This will be 0, 2, and we have here 4. Yes.
4 plus y, 2x plus 2x minus 6y.
So we will equal this to 0 and this to 0 to find the critical point. Okay. So these two functions we can, let's say, we can I said we can multiply something, we can multiply this function, multiply this function by 3. So multiply by 3, so this multiply by 3 here, here, and here, and here. So we have here 12 plus 6x minus 18y equals 0.
But Ustaz, again, why should we multiply by 3? For what reason?
To make something called elimination. We will take this function from here to here and write it here. 4 minus 6x plus 2y equals 0. So we can make elimination. This 6x plus negative 6x is 0. So we have here 0. This is 16 when we add these two functions. And this is negative 16y equals to 0. We multiplied this to make something called elimination. Okay? Elimination, we eliminate the x to solve for y. So we will take this to the other side, 16y equals 16. Divided 16, divided 16. So y equals 1. What?
I said y equals 1.
Yes. Now we will substitute this y equals 1. Substitute in any equation. Let's say at this equation. So 4 minus 6x plus 2y equal to 0. 4 minus 6x. This is 2 equal to 0. 4 plus 2 is 6 minus 6x equal to 0. We can take this to the other side. 6x equals 6. If x equals 1. So our point, the critical point, it is 1 and 1. Only one critical point because we have only one x and one y. Okay? So he said that there is only one critical point. We did it. Classify the critical point. To classify it, we need to find, I write it here. To classify the critical point, what we need? We need to calculate fxx and d equals fxx multiply fyy minus fxy squared. Okay, from fxx and d, we can say that this point is maximum or minimum or saddle. So now we need to find some space. I think we can calculate here, right?
Yes.
So df d2f dx squared is what?
From the first, yes. From the df dx.
Yes.
With respect to x, so it would be just minus 6.
Minus 6. And d2f dx dy. Let's say dx dy. From here.
Yes. It
with respect to y.
It's positive 2.
And from here, d2f dy squared. This will be
-6.
-6. Okay. Now, what is d? D equals d2f dx squared multiply d2f dy squared minus d2f dx dy squared. So this is what? -6 multiply -6, right?
Yes.
Minus
Minus -2.
2 squared. So this is -36 minus 4, which is -32. This is d, right? What about d2f dx squared is -6, right?
Yes, but
So this is, the point is what? D is less than 0, right?
Yes.
When D is less than 0, so the point is?
Maximum or minimum?
لا, saddle.
Saddle?
Yes. Let's see.
But Ustaz, can I ask you a question before? Where did you get D? It's given in the rule?
Yes, in the rule.
Yes, I remember we studied
this rule. D equals fxx multiply fyy minus fxy squared. Okay, and when D less than 0, negative, the point is saddle. If D is positive, we can see if fxx greater than 0, so the point is minimum. If xxx less than 0, the point is maximum. If D is 0, we cannot have any conclusion. Okay? So in our case here, D is less than 0, so the point is saddle. What is the shape of the saddle? You just saw it in the video, right?
Yes, yes, I saw.
Now.
But we shouldn't draw, yes, it. We shouldn't draw the saddle.
No, you will not draw. I need to make because I have an appointment. Let us consider 3 of the functions we used as examples earlier. Find and classify the nature of the critical points of the following functions. This one, this one, this one. So we'll do first one. Bismillah. First step, we will make f df dx, right?
So it would be, with respect to x, it would be 4x. And the df dy, it would be 4y. And we need to find d squared f dx squared. And it would be 4. D squared f dx dy, it would be just 4, yes, 2.
With respect to y, it's 0.
Okay.
Nothing. And now from here, d2f dy squared is what?
4.
4. Now, we need to equal df dx to 0. So 4x equal to 0. And df dy equal to 0. So 4y equals to 0, right?
Yes.
From here, x equal to 0. And from here, y equal to 0. our point, the critical point, 0 and 0, right?
Yes.
Now, what is D?
It's 4 minus.
4 multiply this,
Yes, 4 multiply 4 minus 0.
0 squared, which is
4, 16.
16. This is greater than 0.
So it's
Fxx equals,
maximum or minimum.
huh?
It's maximum or minimum, yes?
Greater than 0, yes, maximum or minimum. So Fxx is what?
Fx, it's a d squared f dx squared, so it would be 4.
4. So this is greater than 0. So the critical point is what?
Is maximum.
No, minimum. If Fxx greater than 0, so the critical point is minimum.
If it would be negative, so it would be maximum, yes? As
Yes.
from a
Yes.
Okay.
That's it. Okay? طيب. بسم الله الرحمن الرحيم. يلا. dg dx is
It's with respect to x, it would be e power negative x squared plus y
squared, yes.
multiply
Multiply.
the derivative of inside, yes? Then it would be negative 2x.
Negative 2x.
So it would be negative 2x e power negative x plus y squared, yes?
Yes. And dg dy is what?
It's a e power negative x squared y plus y squared multiply it would be negative plus 2y.
This negative sign.
Yes, so it would be negative 2.
Negative 2e, negative 2y, e power negative x squared plus y squared.
Yes.
So from here, we need to calculate dx squared, d2g dx squared is what?
It would be negative 2 e power negative x squared plus y.
Negative 2, the derivative of the first multiply the second, which is negative 2 e power negative x squared plus y squared plus, right? Derivative of the second, which is negative
2x.
Negative 2x e power negative x squared plus y squared. Multiply the first, which is negative 2x, right? So this is, you can take negative 2x, this is negative 2x, multiply negative 2x is positive 4x. So you can take, write it like this, negative 2 e power negative x squared plus y squared. We can take this as a common factor. So we have here 1, and this will be positive. So we have here negative 2x multiply 2x squared. Can you see it?
Yes.
Can you see why I did this? Negative multiply negative is positive. Positive 4 x squared. Multiply this e power, this bracket. we will take negative 2 e power this bracket as a common factor. So this will be multiply 1 here, this will be 1, and this will be negative 2x squared because we have 4x squared here. Okay? So this is d2g dx squared. Now we need to find from here d2f, can make it d2f dx dy from here. So with respect to y, the derivative of the first is 0, multiply the second, right?
Yes.
So this will be 0 plus the derivative of the second multiply first, which is negative 2x multiply the derivative of this with respect to y, which is negative 2y e power negative x squared plus y squared, right?
Yes, right.
So a negative multiply negative is positive 4xy e power negative x squared plus y squared, right? Now we need to find the derivative of this with respect from here. We need to find d to g divided dy squared, the derivative of this with respect to y. Derivative of the first will be negative 2, right?
Yes.
Multiply the second, which is e power negative x squared plus y squared, plus the first, which is negative 2y, multiply the derivative of the second,
yes, negative
which is negative 2y e power negative x squared plus y squared.
Ustaz,
Yes.
the first part, like negative 2e power negative x squared plus y squared, I understood. But where did you get negative 2y multiplied?
The derivative of the plus the derivative of the second, this part. Multiply the first, which is negative 2y, right?
So it's like derivative of inner multiply the whole, the previous one.
No. This, 1 minute. This is the first derivative, the first function, and this is the second function, okay? Right? So what is the derivative of the first function is negative 2, right?
Yes.
So the derivative of this is here, negative 2. Multiply the second, right? Now we need the derivative of the second, which is this. Multiply the second, which is this. Multiply the first. This is the derivative of this. Multiply first. Let's say يعني ايه first the derivative of the first multiply second, right?
Yes.
Plus the derivative of the second multiply the first, right?
Yes.
I just wrote it this before this. This is here and this is here. The first is negative 2y, which is this. Multiply the derivative of the second, which is here. Okay.
Yes.
Did you see it?
Yes, I saw.
Right. Did you understand it?
Yes.
Yes?
Yes.
Right. Now we can take negative 2 e power this bracket, a common factor. Negative 2 e power negative x squared plus y squared common factor. And we have here 1. this is negative multiply negative is positive, and we took negative common factor, so this is negative. And we have here 2 because this is 4. We will take 2. So we have here y squared. That's it. This is a second derivative with respect to y. Okay?
Yes.
Now we need to find the point. We need to equal dg dx with 0. Okay?
Okay.
Now, if to find the point, to find the critical point, we need to fix this to 0. So this is negative 2x e power negative x squared plus y squared equals to 0. So this is like this, negative 2x over e power x squared plus y squared. So from this we can find that negative 2x equal to 0. Negative 2x equal to 0. So x equal to 0. Right? Hello?
I'm here. I'm listening.
So x equal to 0, and from here, if we equal this to 0, so we will get y equal to 0 again. Because e power anything cannot be equal to 0. This should be equal to 0. 2y equal to 0, so y equal to 0. So our point, the critical point is critical point the critical point 0, 0. Okay? So now we need to find the value of
Yes.
d2f dx squared, which is negative 2 e power I will take it in another place, and d2f dy squared, which is negative 2 e power negative x squared plus y squared, y minus 2y squared d2f dx dy, which is 4xy e power negative x e power x squared plus y squared. Here we have d2f dx squared equals negative 2 e power negative x squared plus y squared multiply 1 minus 2x squared. And d2f dy squared equals negative 2 e power negative x squared plus y squared multiply 1 minus 2y squared and d2f dx dy equals 4xy e power negative x squared plus y squared. Okay?
Yes.
So at point xy, the critical point which is 0, 0, what is this and what is this and what is this?
Mm-hmm.
We will, so this e power 0, e power 0 is what?
E power 0
Is 1. Anything power 0 is 1.
yes.
Right? You have a
Yes.
negative 2 multiply 1
0. 1.
multiply 1. We said e power 0 is 1.
So it would be a negative 2.
1 minus 0, which is, this is negative 2. And this is what? Negative
1.
2 multiply e power 0, which is 1.
Yes, multiply
And,
1. 1 minus.
So this is negative 2 again.
Yes.
And here, this is 4 multiply 0 multiply 0 is 0. 0 multiply 1 is 0.
Yeah.
Right? So
Yes.
D is.
And we put, yes, we multiply negative 2 multiply negative 2. And
minus
add
0 squared, which is
0.
4.
It would be negative, just positive 4.
So this is greater than 0, right?
Yes, greater than
And
0.
f xx is what? Or d2f dx squared.
Yes. So
is negative 2. Negative 2 less than 0, right?
Yes, so it would be critical point. Critical point, it would be maximum.
Right. Good. That's it. Okay. Now I want to pray Al-Maghrib, and we can continue after Maghrib, 10 minutes.
I also have Maghrib. Okay? Yes, okay, inshallah.
Inshallah.